So object-oriented programming, what is that? Anybody heard about this? Anybody did this before? Okay, and anybody did programming without object-oriented programming? And this is kind of interesting. And what I'm going to do right now, just read this and try to explain a little bit. And this is OOP, stands for object-oriented programming, and it's a programming paradigm, which is about the concept of classes and objects. It's mostly, not only, we have many other artifacts, interfaces, lists, properties, and so on, and etc. But this is not that important. What I'm going to do is actually to make a program with you now in the next, let's say, 15 minutes, do live coding without object-oriented programming. And then I will come back to the presentation and start talking about object-oriented programming. And then we will take this program, what we make now, and try together to make that better program by using object-oriented programming. I think this is the best way to learn something, just learning and doing, and to see the things how they are. And if I start now to talk about some classes and object inheritance and something like that, for most of you who never did that, never thought about this, might be very abstract, and you will not really have a real feeling about that. What is this really? And when you see now how bad it is without object-oriented programming, you will feel much better, more comfortable with object-oriented programming. And this is what I'm going to do right now. So I will jump out from the presentation, and what I'm going to do, I will take a tool of my choice, which is a Visual Studio, and create a new project. This project will be the project type console application, which is the most simplest one, but it's the most important one, because every other project type is based on that one. So I clicked on the new project, and in the new project, automatically I'm going to choose console application. This console application, I will put it somewhere in, let's say we will call it non-OOP, or let's say, don't forget. So it is very simple. This is application will be simple. So solution, and I will call this, the solution name will be open. Project which I'm creating, so please remember what we talked about. If I'm creating the solution, inside of the solution, I might have one or multiple projects. In this case, I will create a single one, which is called PetSend. So then I go to the next, and here there is something. Look at last time as we talked about this, it was .NET 6 or any other framework. Since this week, as we promised, in the context of this .NET Conf, we have .NET 7, what I'm going to choose right now. There is actually nothing new to you, which you have to change in thinking, working, learning, whatever, regarding .NET 7. Other thing, please notice this, do not use top-level statements. This is something new for the people who never did the programming with .NET, who might come rather from some other context space like Node.js or something like that. For that, people would be even better. Not click this. I'm going to do this because I will explain what are some things. Some things are not hidden. So, create, and after the create, I get the project. I will get typical hello world, which you already should know. So when I start this application, it will just write on the application, also write like hello world. So let's do now following. I'm trying to create an application which will maintain animals. Just as an example. So to maintain animals, I wanted to use a console and enter animal name, animal type, or some features which animal might have. For example, animal name can be Fifi, yeah? Animal type, what kind of animal might be the dog, might be tiger, might be bird, might be something. Jill, how many legs, any other features, how many eyes, whatever you would like to have as a feature, you just can think about it, be creative, and the user needs to enter. Let's start writing this application, which is very simple. So what I want to show you now, in like less than 15 minutes, you will see how such a simple application can become very complex. And this problem of complexity, we will try to solve by using object-oriented. But this we will do in the next hour. So let's start this. First of all, I will start doing this and say, hey, never end. So end, when true becomes false, this will never be the case. So this is a loop which will all the time run something. So after doing this, I will come here and say console read line. And console read line is some method which reads something. If you don't know what is this, so what you're going to do, you will just copy paste this or somewhere in browser choice and just type it. After that, you will find yourself on the learn.microsoft something. It doesn't have to be Microsoft. Yeah, but this is, if you've seen learn.microsoft.com and it's pretty okay to you, this is probably one of the best locations where you need to run it. And here, by using of this, you can find someone, what is that? You can see examples and so on. And with every method, as we talked about, it can be from this way. You can read about this, how to use it. Important here is that when you read that, you will get something here which is called string. And because this is a string, here will be the output of this string. So I can do this with string result equals something. And when using this string result equals something, look at what's happened here. There is something here, some small warning. And you know what is this warning? This is a pretty new feature in .NET Framework and in a C#, which help us to avoid null reference errors or exceptions. And this thing here tell me if when the user enters something, it can happen. I don't know, but probably it can happen that what user has entered might be null reference. It means nothing. And this could be problematic for you. Or maybe not, because it doesn't know it is a problem or not. It gives you warning. It warns you and say, hey, what? Please take care about this. And if you do this, there are two ways to fix this. You can say, yes, I'm fine with this, that the user enters something what might be a null reference. In that case, I will type in this question mark. That means I'm fine with that. This thing can be that. Okay, why is this problem? The problem is if I don't have this and start dealing with this rest. For example, I come here and say rest, give me the length of the string. If this is not a string, or it is a string as a null reference, this will crash. And the Microsoft did some measurements and so on in testing on a software, and they figure out that almost, like say, that's not exactly number, like 90% of errors which we have today in the software based on .NET, it is something about null references. And they figured out that a few years ago and say, okay, let's fix this and help developers by putting such messages in the warnings inside of the code before they start running the application during compile time to help them make the right choice. And one of the right choices would be this one. And I say, hey, this is okay to me. No, it's not okay to me. It is I expect it can be. So if it can be, then I can write here if rest. Sorry. If rest equal null, I can do something. It's not equal null, I can do something else. So I'm not going to do that, spend so much time on this. What I really want to tell you, but because we are learning the software engineering and Visual Studio and .NET, this is some very important helpful feature. Another way to do this is if I'm not expecting null, and whatever the reason might be for that, to prevent this error happen, I can put here, come on, so this is now, sometimes it's not really real time, sometimes it needs to compile, sometimes need to wait seconds, maybe a minute, and so on to make that happen. After that, there is another, at the end of the line, you can put something like this. And this means I don't care. Just ignore it. Okay, and you have to be careful with that. If people start doing this, putting all of these all the time, which is not probably okay. In that case, it is pretty fine to do this. So what I'm going to do now is the user is entering something, and before user enters something, as following console, right, find, and save the name of the enemy. Okay, and then the user will enter something, and I will have result here, and I can use this result as the name of that. It's very simple. Okay, so let's copy this, and after user has entered that, let's say please enter the kind or type of animal. I don't know what is the best to say that. It will be bird, dog, cat, whatever, tiger, and so on. And I will say here, this is an animal kind, and the user will enter it. What else we can do? I can use following. So please enter the number of legs now of them. So this here is all what I'm doing here. It is called animal property of feature. The property, leg, name, time, and so on. And I can have many of these. So let's stay with this just brief. And I will write this here now and say number of legs. So the problem with this number of legs is whenever user enters something like this, it is what kind of type in DotNet Framework. It is a string, and I'm expecting something like number. So there are different kinds of numbers in DotNet Framework. One of this is integer. And to make this happen as an integer, I can say here, okay, integer legs equal, and integer parsed num legs of the integer. Here you have to be careful. I have no time now to demo everything here, but sometimes this what user has entered as a number, it is what is supposed to be number. Maybe user entered something like blah blah, and blah blah is obviously not convertible, parsable into the string, and this will fail. For that kind of errors, there is something like integer try parse number of legs. So I can also show you this. I can write this. So I say this is a number of legs. I put it here and say, okay, most animals have 4 legs. Just wanted. Let's say, and I can come here and say integer try parse number of legs into the number of legs. So what should this happen here at the end here? I'm getting some result which I'm not interested in. That one, this result is did I parse it successfully or not? So if it's parsed successfully, it will output the value as a string into the variable of type integer, which is called legs. Okay. If I enter blah blah, it will not do this. It will just ignore it, give me some false, which I'm not interested. But the value legs will stay. Which number? Default one, which is 4. Did you get it? So I'm really going easily, step by step, to make application. So the question is, so this is how it works, and let's do following now. We can do here console right now. Now it's supposing me, suggesting me what to do. These are artificial intelligences. We can talk about it, which is building in Visual Studio, and I can see here, please enter and for next animal or exit. Okay, so what will happen now? So I will this while user result equal post read line, and I will have user result. Then I will do here if user result equal edit. Or we can also do this, user result. Here is method, but you know that. I will break this group. Break means exit the loop. If I don't do that, it will go now to the next one here. So it will just loop all the time. So, and I will enter the animal and so on. Okay, would you like to start it? So let's start that. And I will put the breakpoint here. The end of the loop. Let's start that. Any questions so far? Good. Enter the name of the animal, Fifi, type of the animal, dog, how many lengths, 23. Please enter for the next, or let's do next. So please enter for the animal is Ellie, cat, number of legs, 2, and please exit. So that's it. You see, it's fine. It's a crazy application. So the problem with this is now how to store this data. And any idea? Okay, let's do following. We can do following and say, I will talk about this later on, what is static primary. For this reason, not using you, I will say it's a list of string. I'm building the list of string, and here is names, animal names, and it initializes automatically to the list of names. I can do the same now, and I will say here kinds. Then the next one would be integer, and here's the integer. Okay, did you get the point? So I have lists, and every of these values I will just put in the list. If somebody has some other idea, we can do something else. There are probably endless, more or less, possibilities to do this, but this is one of, I would say, the simplest one in this case. I'm not using object-oriented programming. And imagine now we would be in C now, C language or something like that. So let's put that and do following. At the end here, before I exit the loop, I will say names add, and I will put the name of the animal in the list. I need here static. I will talk about it later. Names. Then I have here, what else? Kinds. And then have here legs. And here is kind, and here's legs. So what's happening now? So I'm creating the list of animal legs list. I will change this. You see, I have an error because legs. I have variable legs here, and legs here is not load. So I need to choose another name. Let's say no legs. Sorry. So you know what's going on. So I'm filling up the list with these elements. At the end, I can do also following. If the user doesn't exit and wants to have a next animal, we can say here print animals. We can create some method which prints the list of animals. Because I don't have this method, I say control dot. And control dot provides me here possibility to create a method. It creates an empty method. So this is how it works very fast. So you can use many tricks of Visual Studio. So I can do following now and say, hey, make a loop from names. Count. Through all of them now, and we will write down something. Before we write down something, we may do a little bit cosmetic here. Console right line. And what you're doing here is something like that. Still, you can use now here something like console right line as empty line before that, or you can use the empty line like doing this, Control R, Control M. This is control cycle carriage return new line. And I can also use this. This is coming actually from C, and I can do that. So it's the same thing. I'm just trying to show you as much as possible tricks and things which you can use in Visual Studio. So let's go to next. So we are writing now. We write as a console, right line. And what I want to write here, I will write names of which will show me the name 0, 1, 3. So I'm going to the list. This is how I'm accessing the list by index. Okay, to do a little bit more cosmetic, if people know what we do, I can put that here and use this formatting, say name, and this curly brackets. I copy this. And here is the kind. And here is the length. Times. And this is what we work. I can do also a little bit more. Let's say always it's good to have some identifier, which is actually in this case I. This is the number of animals. So if somebody tell me, hey, give me the animal number 378, I will just go to the list of animal, return 378, and show up this animal. So let's start this episode. And at the end, last but not least, I can do something like this. Just one. Just one empty one. So bring the animals and so on. Let's start at once. So far, so clear, everything?
Yes.
Good. Enter the name of animal, kind of animal, number of legs. On to the next animal. Cat. Or and enter and exit. So I will exit that. I messed up something. What I messed up? I didn't do this. Okay, so I'm here in the loop. You can close the loop. And when I exit the loop, I need to run. So let's start again. So it's a little bit of time, but let's do everything perfect. Start. Okay. One. And now it's writing. Identifier 0 was the dog, then 50, and so on. So this is how it works. Let's take a look at our code now. Okay, this is a code which is doing all this stuff. Imagine now we want also to enter birds. So what has a bird, what dog doesn't have? Wings, for example. So, and obviously, the more precisely you want to do these things, not animals, it can be anything, yeah, in industry and so on, any kind. Animal is entity we are talking about. And that can be very complicated. So let's provide a feature or property which is called links. Links. Now, I can come here and say, if kind of animal equal bird, what I will do here now, I will come here and say, copy paste this, all this code, please enter the number of wings of the bird. Very easy to know. Huh? No. It's actually the same. And here's num wings. At the end, what I'm going to do here, so I will put all this here and here. Follow me. Wings. Wings. This is how this goes. What? I don't hear you. Which line? 34? Num of wings. You are great students. So, num wings. No. Wings. This is what I mean. Okay. So, and look at now here. This seems to be okay, but it is not. So why?
Because we have added everything in the same program.
That's correct. He said because we added everything in the same program. That's not what I wanted. You're right, yeah? Because we know that this is bad, yeah? I just want to show you a few examples why is this bad. Look at here, exactly on this place. Forget there is no object-oriented programming. I'm just sitting down here, and I'm doing this. And look at what happened here now. If it is a verb, the list of this number of wings, wings list, will have a different number of entries than all other lists. So, and for this, why? Because I will enter the dog, I will not enter anything in the wings. So, and that's a kind of problem because I need additional codes to handle this. So what I would do now, what do people do in non-object-oriented programming? If it's not a bird, okay. Let's see mine. Yeah. So it's a good trick, is help me. So I will, with this, I solve the problem. The total list will always have the same length, and I can really just put on the list what I need. And somewhere in the code, I will say if entry wings of something is -1, it means, oh, it's not a verb. So, and every time you introduce such kind of condition in a program, it rises the complexity a little bit, little bit, and little bit. On the beginning of programming, we had assembler. And in assembler is, if it's something in this register, then it's this. If it's in this register, then it's this. If it's 0 and 1, after it suddenly means this, and mean this, and mean this. And after 3 years of running of this program, there is no any human on the planet which knows what's going on with the program. You see, I'm programming for 15 minutes here, and already now I'm introducing problems which I need to solve. And imagine now I have not these 4 features, yeah, name, kind, legs, and so on. I have 4,000, 400, and 100 is just normal in normal application. So this will be everything in one file. Maybe I will put it some other file, and well, I don't know. Yeah, it's not really the best way to do that. So then the people say, well, start thinking about this and say the software is getting more and more complex. So 40 years ago, yeah? But today it's even more complex. Let's try to find something better for this. And I will switch back now in the presentation. And let's talk about something what is called classes. What does this mean? This is exactly our example. Look at now. I can now I have kind of animal, dog, cat, something. And all this stuff like breed, size, age, color, legs, name, whatever, yeah? This is just one example, are called how? Properties. Properties of the entity animal. But what I didn't talk about now is we can also have a function on animal. I can command the animal and say, sleep, eat, get up, whatever. So I can have many, many such commands, statements from this. So let's make one. I exit now in the application. How to do that? I will write, in this case, in this or something, which is called function. And the function is like this. And I can say here for the sleep, which animal needs to sleep? I will say here, none of sleeping hours. Okay, I will call a function in my input as animal and say sleep 3 hours. But which animal? I need to provide, in that case, something, some identifier for animal, and that will be animal ID. And then I will come here, I need to store this. How to store this? Need another list. And we'll call this sleep hours. And this sleep hours plus equal none of sleeping hours. So I will increment number of sleeping hours. So I have a feature later in my application to do statistic and say animal number 378, how many sleeping hours did you have? How much food did you eat? And so on. And this is how application grows up in number of properties and number of functions. This entity. Did you get the point? There is one thing that they didn't say that we have no time to do everything, but I will say if sleep first count I can do that. Argument exception. Animal with specified ID equal ID. Then what I need? I need a dollar sign. And it will write, this is always good to write to the user, hey, I hate this when the program says, hey, I'm crashing now, you specified something wrong. I say, what? So online banking, there are 100 things, the number, IBAN, and blah, 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 and at the end there is some dot missing, yeah? Tell me that it's not missing, or if you know that that's correct, yeah? Be good to your customers and to your users, okay? So this is what we did now. Did you get the point? So let's make it simple. We go in the presentation. So now we can somehow create something to provide the non-properties and to provide the methods for every of these things. And let's call this thing a class. Let's just call it the class. So the class describes some entity you want to deal with. And every time you create an instance of this specific entity, we call that object. And this is a difference between the class and object. The object is the instance of the class. If I have a class animal, I can have endless instances of animal. Every single animal in the nature or science fiction or whatever is instance of a simple single class called animal. That's the difference of this. Class is some abstract thing, and object is instance of it, and instance of this always a physical thing. Next slide. Another entity. Car. Just one example. It's not bird, it's car. It can be fruit, it can be whatever you love. It can be building. And the building can be hierarchically created by building, room, objects in the room, not class objects, just objects, like a bottle, table, or something like that. And this is how that works. And in this case, every car has a features, has a properties, and can have methods like drive, brake, fly would be nice, but it doesn't work. And that's how it works. Okay. It's not a good animation. This is one example. How to create a class in object-oriented language. It's almost all languages very similar. This is in C#. The class has the name my class and has a field which is called counter. And that's here. This is called accessor. It can be private, public, or protected. Private means if this variable, in this case field, I will explain what is field and what is not, yeah, can be seen only by members, methods, inside the same class. So that means if I watch in this class, my class from outside, yeah, I'm outside in my code and watching this class, I see only that on the class what is marked as public. I don't see anything which is marked as a private. There are a little bit more there, like protected and internal. I'll talk about that later. Private, only me inside, public, everybody else, me too. So, why is that good? You will see. This here's property. Property is actually just like a field with difference that when you touch the property from outside or from inside, you think it is a field. But behind implementation of the property can be the code. For example, here's the code which say, I will give you counter multiple 2, for example. It has no any meaning. But somebody who say, my class dot status, it will just get a number. But it doesn't know that this number is every time calculated. So this has sometimes advantages, and you should always strive to use the properties at the beginning, yeah, until you get the feeling when to use properties or when to use methods. So, and that here is example of the method, get result. In the case of animals, this would be method sleep, yeah. In the case of car, would be drive. It would be something. So you can have as many methods and properties as you like. This is the class. It's very simple. Okay, so let's go follow it. Let's create new application, the same one, with the classes. New project in the same solution. Console application. OP sample, object-oriented programming sample. .NET 7. We don't need this. Right now, so if I hit F5 now, what will happen? It will run this project because it's called the project where we start. Now I want, when I hit F5, right, to start this one, say right mouse click, set a startup project. You can also do it here, change it here. Some people like that, some people, I like this because every time I'm looking, if I have 10 projects, I always see bold here, I know which one to start. Okay, so now, right mouse click, add to project a class. So please be careful with that. In your projects, you will need to make many of them. I'm creating a new class. And the class is called animal. So I will put this class public because I want the people using it. Internal means public inside of the same project. Other classes, members of the same project, can see all my internal members as it would be public. Everybody else outside of that wouldn't be able to do it. I will show you one example later. Huh? Here's a constructor. Constructor is a method which is executed when the instance of the class is created. Always. So let's do following now. And come here. I type prop tab. And it creates to me automatically property of type string. Property will be called name. What was the next one? Kind. The next one was legs. And what was this? Wait. Okay. The thing is saying now, non-nullable properties like name and kind and so on can be null when the instance of the class is created. If this is fine, to you, what you will do then, you will come here and say, hey, it is perfectly fine to me be nullable. But in that case, I need to tell the compiler with this question mark. So see, this is 11. Another thing to fix this problem could be to say here, a string kind, integer legs, integer wings, and what else I need? I need some ID. And for this case, so prop tab integer ID. Okay, so this question in my case, solve the warning. But in fact, do you really want to have an animal with a name? Without name, or wings, you don't. Yeah, maybe there are some properties, yeah, can be, but not this. So in that case, I cannot do that. So all this thing is not correct. And I will remove this. And when I remove this, I will get this warning again. I can also remove this if I say, hey, number of is 4, yeah, or something. But this is also not correct. Maybe if I have something, some word or something like that, I cannot have 4. And in this case, I will do this dot ID equal ID. And if you see something here, which is great, this dot kind, look at great, it means artificial intelligence. In that case, if it's correct, tap, it's done for me. Name, legs, wings. Okay, I'm done. And there is no more warning. And in this case, this is how when somebody called this constructor, then this can be null. So if you don't want this, I can remove this. Okay. Now I have a class with 4 properties, and I need now methods. If you want to do that the professional way, what do you typically do? Here, properties. And put everything in the region properties. And I'm organizing my code now in a better quality and a nicer structure. In your project, when we do the review, this is the first thing we check. If somebody didn't organize project this or similar way, and this is the way how we do it, yeah, it means to us it's not complete, even if you say it's complete. Yeah, it's not. Because of this, you will probably not fail. Huh? But this is mostly indicated that many other things are not okay, because you didn't have time to take care about small things. Okay, now, region constructors. Well, just an example. And last but not least, region methods. It can be private, public, and so on. I'm not going to complicate that. What kind of method? I can come here now and say, hey, this is my method. I will just copy paste from this back project, come here back, and this is my method. But now I will put this guy up there. Want the people call me? I'll show that in a moment. And what is sleeping out? This is a property which I have forgotten. And in that case, I will just. Hours. Any questions so far? And look at here now. In this case, I do not need any more this ID property. Why? Because I have it here internally. When the instance of this class animal has been created, somebody from outside must specify this ID to this instance. Okay? In this case, I do not need it. And here will be this dot identify. And I do not need any more this check. What's wrong here now? Sleeping out. Now, this now is also a little bit simpler. Because I have encapsulated some information of my entity inside of the entity. It's not coming from outside. People do not need to take care about this. It's just in there. And I reduce from 5-6 lines of code into the single one. This is just one example. Just one example how this is simplification of it. So this is my method, and I have a program now. So now we need something like this. We need this loop. How to do this loop? I can copy paste the loop and put it there, but no. I want to make my program integrable and simple. And for this, I'm going to create another class. And this class, let's call it it's just some class which is processing user input, yeah? User input processor. And this is a class, and I will call this class public. Input processor. And this input processor will have a method, public. I will put this method now, let's say, void means doesn't give anything. And suggest me, hey, if the class is called input processor, probably this method could be called process. Let's say it's a pack. The process using, I don't need any input for that. And I need to implement this method. To implement this method, I will copy everything from here.
I have a question.
Just a moment.
Yeah.
So who was that? Yes, please raise the question.
The question is that in some article I read, this, even though if you don't use this, it works. And like sometimes it just says that it's redundant. So I removed the this property and it works.
Sorry, I didn't really understand you. I understand you acoustically, but I really didn't understand which property you're talking about.
Using the this keyword.
Test keyboard.
The this. THIS.
Okay.
And even though if I don't use it, it works. In some articles I read that it's became redundant in later iterations of C#.
I'm not quite sure how can I answer it. Did you get the point? I'm not quite sure.
It says that even though if you don't use this, it works.
Yes.
That's what I'm trying to say.
Yeah, that's it.
So,
okay. But we can let's put this question at the end, yeah? Then we can more precisely discuss it. Okay. Okay?
Sure, sure.
Okay. So let's go back now. And where we stop right now, we are here. I just copy paste code into the class in the new method, which is called process. And in this process, I have something like this name. So I have no more this list. So what I'm going to do now, I will create a property, or let's say field, private field. I don't want anybody from outside touch this. And this private field will be a list of, well, let's say string, but it's not string. I will say animal and put this animal. Of instances of the type animal. So, and I even don't want to have this property here. Let's do this, put it inside of my method. And every time I have something like this, I'm not going to do that. I will say animal. I'm creating the instance of animal. And what I need to provide here. Identify, input, count, +1. Then I have a name. The next thing is kind, number of legs, and so on. This is what I have created. But this thing will also want to have wings. And it's complicated. So how to put the wings here? Okay. In this case, I can put here something like -1. Okay. There are many ways. It's still not good. I just want to lead you into that, but make things complicated. I create an instance here. But if it is a verb, then I will take this animal, an, and say wings equal not wings. So first I create the instance with something crazy, which is not okay, and then I will replace it with the correct one. Again, doesn't feel good. So previously, remember, I had to introduce a new list, and the list didn't have the same number of elements, and I had to fix that. Now I will need to fix this, which is not too bad. It is inside of my method, and nobody sees this code. It will not destroy so much if I'm responsible for it. Let's talk about that in a minute. Just remember, this is not nice. So you need a special dealing with that. So what is this here? Okay. Oh, I don't need this. Again, simplification. Less code. So what I have now, I have here now the same processor, which is running, entering user and putting one last thing is at the end, I have to go here to the list of animals. How it's called the list. Input. And I will put the animal. I don't like the names here. Double click. Control R. I'm replacing that now. So Control R. I'm renaming that, and I will call that animal. And look at this is called refactoring and renames in that case, and it's changing all instances of that. And this here input, I don't like this. Control R, rename animals. List of animals, and at the end, I can say, hey, this processor, when it is done, it should return the list of animals. I have created a class here, which is input processor. And it's taking care about user input. So, and I have created a class of animal, which will be part of this user input. Processor will create this input and give me this input back. So let's use this now in the code. Look at my code has nothing to. So I will come here now and say input processor I create a processor. Processor has a method, which is called process. That's it. At the end of this, what I will get back, animals. So now there is a thing which I will put that a little bigger, so, which I promised to tell. So, and then imagine now I go to this processor and I close this method and I create another method. Private void private method. Then I create a method which is called internal method. Just to show you the difference between these accessors. And then I will have something what is called protected. And I will talk about protected a little bit later. And let's come here. And I'm a processor now. And look at it, dot. Oops. I press a dot, and dot show me internal method, method process, which is this one. And where is the protected and private? It doesn't see. You, as the user or developer of this class, you don't know that it exists. You don't want the people to know that. It's your thing. Okay? This is how that works. And there is also something else, like static method. And static methods also have access to the private, everything has. Also properties and fields. It's always the same. If the method is a static one, static method. I need a void. Void means no return. It's procedure in some other language. And look at here, wrong. Where's the static here? There's no static method. So the static method means when you want to call me, you don't need the instance of the class. You type the name of the class and say, type the method. Okay? Sometimes this is good to have. And it is always good to have static methods, better than have so-called instance method, because they are a little bit faster. And you can have static methods only then if the method does not need to touch some properties and fields inside of the class, which are not static. So why it is faster? Because it is not faster because during implementation of instance methods needs to be put somewhere in an address table in the memory, and static methods are put only once for the type. And if you have millions of instances of the object, every of these methods will be millions of times somewhere stored in the memory, which blow out the memory, and every time you need more and more memory, you program will sometimes get slower. So recommendation is if you can use static methods. It doesn't mean if it's public, private, it's totally different story. We just use it. Okay? So this is about static methods. It's about methods, about accessors. So when I run this now, would you like to run this? So let's start this. So enter the name of the animal, enter the kind of animal, please enter the number of legs. So do you want the next one? Don't want the next one, so I exit the application. So everything works fine, but look at your code. This is just 2 lines of code. So, and somebody can say, nah, behind this code there is more code. Yeah, it is. But this code is encapsulated somewhere. And if you have problem now during input of the data, where are you going to fix it? An input processor. You understand? This is very simple application. If you have hundreds of classes, and usually we have thousands, yeah? You don't know where to start. You don't know where to start. And believe me, today's software is the quality of software. That one of the most complicated things in software to make is to make it maintainable. Your code is perfect if other guys can learn it very quickly. If you have code, hey, this guy is the best developer in the world. Look, when he writes something or she writes something, nobody understands. This is not good. Good developers make complex things simple. Everybody can make it complicated, assuming the people are smart enough. Yeah? So this is something, please remember that. That's very important.
But then isn't it sometimes that people intentionally make it complicated so that if some problem comes, then the person will only resolve it?
So he's saying, isn't that sometimes the people intentionally make it complicated? Of course, I do too. And sometimes when we take a look on that, what we did a year ago or 2 years ago, every next time we would start it again, it would be a little bit different. Why? Because we learned the lesson. We know now better how to do it. And then somebody can ask question, why didn't you do it immediately? Because we were not so smart at that moment of time. And this is not bad, because we always learn. It's not, we don't learn necessarily how to make a better program. I don't think I will learn next year better programming than today. And so you will be good programming 2-3 years, or 5, depends on how much you're doing. Yeah. But I'm talking about application, user. This is something that we learn and people and your user learns. This is improvement continually. This is totally normal thing in the nature, not only in software engineering. Okay, that is how it works. So let's come here now and continue making this application. So I have now my animals, and I want now to print these animals. And if I want to print animals, let's make another class. I want to do good object-oriented programming, and I say, this is animal printer. Or let's call it simple animal printer. Okay. And now I'm going public. And creating the class, I'm creating the method, which is called and I will put into this printer here. I can do following and create a, and inside constructor, I can put a list of I will have a property, or let's say a field. In this case, I don't need a property, it's a simple list of animal. I will need this, but in the constructor, I will make sure that these dot animals list with that what I have provided. And this guy here will go to every animal and just print it out. How to do that? I will come here and just copy all of this and do some small changes. And I will do that. I will come here for each animal in animals. I will do this. And I don't need this, but I have ID. This is my member variable. Actually, I can write this dot this dot sorry, not that. That's animal dot ID animal dot name. I don't need these. Animal dot kind dot lex else wings. Yeah. But this means it's still kind of not cool. It still doesn't feel good. It still doesn't feel good because if the animal is not a bird, if it's elephant, it doesn't have wings. That's a problem. And I need still to write it here. So, but let's start it. And then fix that problem. It's not the problem, it's not a nice thing. And how it's called our Conf? Input processor simple animal. To provide here, I need to put animals inside. So actually what we could do here, we could do this. This is what the Python developers would do. But this is not good programming. Yeah, we are not on functions, we have some mad stuff. It should be readable because I can put the breakpoint. Yeah? If you put the thing here, very difficult to put the breakpoint here. Yeah, is it breakpoint here or here? And I can even do this. Look, I can this. Processor, process. Look, this will work. But please don't. Well, is that readable? Everything in a single line, of course. Somebody say, hey, look at this is cool. In one line, of course, I solved the problem. That's not what we are looking for. Brilliant. Nobody can read that. So what I'm going to do, Control Z, that, and make it nice as it should be. Look at, I can breakpoint here at the end. I can do that. It's printer, print, and I will print all animals. Let's start this once and to see if it works. Enter the animal, it be dog 44, next one, Papa, bird, number of legs 2, number of wings 4, enter the name. So I say exit now, and now it brings all of it. Look at everything works fine, and my code is just like this. Now, you can organize even your team and say, hey, the software architect is the guy who will make this direction. I want to have the application like this. And I can go here and you are going to implement the input processor and you are going to implement this printer. And we can have 3 guys and done in 15 minutes with all application. You can organize code. And imagine now, let's go here back to our web example and try to organize anything here. Just take a look at this code and this. You cannot organize. That's problem. And at the beginning of software development in 40, 50 years ago, the program was just small like this, yeah, and mostly one guy did that, and that's it, yeah. Today it's not. You have application which needs to run. We have applications today. My oldest application is, I don't know, 16, 17 years old. And it's still running and still maintaining and so on. Imagine now if we wouldn't do it this way, it would be very different. Extremely different. So let's go now follow. Sometimes interfaces. Interfaces are contracts. So they are not classes now, it's something else. It's a contract. And contract doesn't execute, it defines how to implement. Imagine now we would be lawyers and we make a deal and define contract between us. And I tell you, hey guys, when you implement this input processor, how we would do that, yeah? It should be nice, it should be feel good, it should be cool, it shouldn't crash and so on. And we put it on the paper as the people do it. So, and then you implement it, they give it to me, and somebody said, oh, it's okay, but it doesn't feel good. And somebody else, oh, I think it feels good. This is how it works with lawyers. So an engineer say, no, it cannot work this way. Let's make kind of contract, and when we agree on that, it's clear. No left, no right, no, I think so, you think so. No, we make a contract. And this contract we compile, share between us, I give you, and everybody make. Imagine now following. Input processor. I give you to make input processor and give you to make input processor. Both of you. And I pay for this. But at the end, I will use only one, maybe two. I don't know. But I want to be exchangeable for me. If I tell you, could you implement this processor, you implement it, if I come next day when you implement, both will work, but it will be totally different. And it can be so different that I'm not able to use any of them. So how to do this? The interface looks like this. Class here, you just define methods and properties which you need, but there is no implementation. So Visual Studio might help you, because when you come here to input processor, you can go to right mouse click and say extract interface. So I don't want to type it. Okay, and to extract interface, I click on this and say, what is the name of your interface? I say it is I input. There is convention, naming convention inside .NET and most other languages that interfaces are prefixed with I. Okay, and let's call this one I input processor, and this I input processor with from all public methods and properties. I have only one public method. Will create interface. So, and when it does happen, it will say this class is implemented as interface. It's according to this contract which we did between us. So what does it mean? Look at that. I can compile this. Look, let's take a look. So created this interface says you need one method. Now I come in here as a lawyer, as architect, and say, I want this input processor has another method which is called cleanup. Doesn't matter. So it has to clean something. When I have this now and I compile, what will happen now? I will get an error. And I will get the error in this input processor. And this error tell me, hey, nice, but you have implemented, but you didn't fulfill the contract between us. And contract says you need two methods. One is which you implemented, but this method, there is another method which you didn't implement. Show potential pixel. They say, do you want me? I implement this method for you. It's empty method. I said, yes, why not? And now look at it, it compiles, but this method is now clean up and say not implemented exception. Okay. Now developer goes there and implements what's his cleanup. But did you get this? It is a real contract. If somebody say we agree on that, the compiler checks that you didn't agree, and it gives you an error. This is interface. Okay, so now I will remove this cleanup here. I don't need it. I will come to interface here. Also remove this cleanup. So what I can do now, I can implement another class. And this another class, I best input processor. Yeah, I think I can do this better than the professor, and I will implement my process. And what I need to do, it must be public. And I will say I input processor, and this I input processor say, hey, you need to implement it, control dot, implement interface, and it implements this method for me. And this method can be I must process. And going on. So this would be my thing. So if I want now, okay, I copy this in processor here and go to my program. In my program, I'm not going to deal with input processor, I will deal with interface. Okay, and I'm not changing any code here in my program. I'm not changing any code. In this case, I know that it will be, in this case, executed this input processor. What I could do here is my input processor. Okay, I just changed it in a single place in the code, the implementation, use the same interface, and I didn't do any change in the program. This is about efficiency. Imagine all this program is for 5 lines, of course, it's 5 million lines. And you have this input processor in 500 places. You need a week to do that. And after this week, you are not sure it will work. Then you need to pay somebody who will test and so on. Yeah, I need to do it. Yeah. But let's start this thing. What will happen now? Because this is a fake, yeah, it will not do any input. I will run this, and here after that, this thing gives me empty list, and because it's empty list, it doesn't print anything. Oh, sorry. It doesn't print anything, and nothing happens. But I know, oh, this guy has implemented this interface. I'm going to call these guys and say, please, would you do better implementation of this? This is about interface. So now let's come back without interfaces. This is one last thing here, and then we will close this chapter and then make a break. So you remember our words, that we have some problem with words. Let's come here and say, obviously, I need to fix these words below, yeah? And I need a concept, yeah? And this concept is a class which is called word. And this class will inherit or derive, the same thing, animal. What does this mean? It means the bird has everything what animal has, and also something else. So I have a possibility to extend the animal to give additional features, but only for a specific type of animal, which is a bird. How to do that? What is this thing saying? Actually, animal, if you want to create instance of animal, you need to call constructor, like this one, to create the animal. Where was this? This was here. To create animal, you have to create animal like this. This is what it is saying. So if you are inheriting from animal, you need in fixing generate constructor word. Yeah, look, it creates a constructor for me, the same one, and call the base constructor of. So when somebody says new word, and I specify name, blah, 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 it will automatically call animal constructor and set all of the parameters. So what that this means, this thing I don't need because animal doesn't need to do that. Be careful now. I'm going to animal and I copy out links to the bird. This feature bird only, not of animal. This is exactly what I get. And I don't need this. This I need here, but I don't need it here. Fine. So now somewhere here, I have this dot rings equal rings. I set here rings, and then after this execution, the execution is first here, then I'm going into that OS process. This one is actually in construction of n because I have it to n. Are you still with me? I hope so. I hope so, you too. So I created that kind. So, and now it's interesting here. Let's first fix that. Base. I don't need this. Yeah. And this is also absolute. So look, everything compiles. And now, if I create a verb, I don't need this. It is verb. Move that. So, but it says, tell me now, animal, to create animal from here. What else now? What will you give me now? If you don't specify, I can specify here, it is a verb. That's it. So now I will come here in input processor. In input processor, I will link this. This was a number of links. And I have created animal, but here's now interesting. I don't have this. So how to fix that? So if it is a verb, the verb, I will create this. And let me see if I can do that. Animal, animal. Animal. Are you with me? This is now coding, it's a little bit sometimes verb. Here is identify, it was what is identify? This. And I say this. Come on, come on, come on. Name. And wings. Let me do this. Kind I don't need. In this case, is as it was. Did you get the point now? This is how it works. What we have talked about. First, we started the program to deal with animals in a bad way, and procedural language, not object-oriented, and we figure out, oh, the code is too long, we have so many lists, and there are some conditions, and it's not, it works, but it's not so good. And then object-oriented was really, we can make modules, classes, and we have separated input, output, and we did some processor, and everything was a little bit smaller, easier, and so on. And then we had the problem between animals and birds, and we squish all this together, and we split that. We did first animal as animal. This is called base type. Then we created the bird as another type. It can be so, but using that approach, we can, for every some specific kind of animal, mammals, I don't know, we can create a type and proceed with this. And last but not least, we talked about interfaces. And interfaces, we said these are digital contracts, which fix us, which give us a possibility to agree on the contract between us. And when it compiles, It tells us if we do some wrong or correct. And this is how it works. What was the advantage of this? The advantage was here we were able to use work by interface, and we change only the class here. Input processor can be that one, that one, that. I can have hundreds of implementation of this. Okay. And this is now about words and input processor. There are so many examples of this. For example, cryptography. If you want to encrypt something, you as a developer say just encrypt. And behind this encrypt method, this interface, with many implementations. And these years, we use this implementation. In a few years, this implementation will be a problem. It will be too weak because of hacker attacks and so on. We will have some other one. The interface remains usually the same, and implementation change. So the Windows bring you new implementation, and your code is still running. You don't need to change. Even if there is some error, a bug in encryption, it will be fixed if you call it still running. It's fixing with some other module. And this is modular programming, which is possible by object orientation. So thank you so much. Let's make now 15 minutes break. And we are talking about next more advanced topic. It's called dependency injection. See you guys.
You don't have.
This is different. Change. You see when I create a new class. Correct. In the properties, this is like that. This is called Pascal. So, see it? You mean without problem?
I mean, not the public.
So,
Yeah.
we can, yes, but suddenly the one problem. Here. Anyway, I mean programs. I put them. So I can change. For example, if I can also change if I want to prevent this. In this case, it will give me error now. But this the question was why I didn't use private, because in this specific example, I could use private, you are right, because I but usually we design animal.
Contracts the interface and the classes. I input processor. I input processor is contract is interface. How about animal and bird? Inside bird, we are implementing animals. So we are taking few details from bird and inside bird.
Inside bird.
Yeah. So we use again the same column. What is it? What is it called? It's partially all the fees from animal inside
Yes, look.
bird.
This is here, for example. This is. That's a name. Yes, legs. Wings. If I go now to.
It's separated. These are only for birds with kind of. So is it called bird class or something? So like the phrase is for some method implementation. Abstract or something. Okay, interface. I input into processor has input processor down because individual implementations we can say. Animal.
Abstract, that's not.
Does animal and bird learn the same?
No, you can also make interface.
We have another example like cars. So in a car, or car things like that. So if it's kind of an electric, or maybe automatic option also there, then it will be like coming
You
in
can have a new class.
What I'm asking is which operator is according to